Welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, unit 4, chemical bonding and molecular structure. And in this video, we will discuss about overlapping of atomic orbitals and sigma and pi bonds. First come to orbital overlap concept. In the previous video, we have discussed the formation of hydrogen molecule by valency bond theory. In the formation of hydrogen molecule, there is a minimum energy state when two hydrogen atoms are so near that their atomic orbitals undergo partial interpenetration. The partial merging or partial interpenetration of atomic orbitals is called overlapping of atomic orbitals, which results in the pairing of electrons. The extent of overlap decides the strength of a covalent bond. In general, greater the overlap, the stronger is the bond formed between two atoms. Therefore, according to orbital overlap concept, the formation of a covalent bond between two atoms results by pairing of electrons present in the valency shell having opposite spins. Okay? When orbitals of two atoms come close to form bond, their overlap may be positive, negative or zero, depending upon the sign and direction of orientation. Okay, sign means phase and direction of orientation of amplitude of orbital wave function in space. Positive and negative sign on boundary surface diagrams. We have discussed about these boundary surface diagrams. When we represent the orbitals as boundary surface diagrams, we mention the positive and negative sign. These positive and negative sign on boundary surface diagram show the sign or phase of orbital wave function and are not related to charge. Okay, orbitals forming bond should have same sign or phase and orientation in space. It means same sign of orbital wave function and same orientation of orbital wave function in space to form a bond. Okay, and this type of overlapping is called positive overlap. For example, see these diagrams which representing positive overlapping. This is pz of one atom overlap with the pz of another atom. Again, remember these minus and plus, these are not the charges. These are simply the phase of orbital wave function. Okay, that is these two. We can say the phase of these two atomic orbitals are the same. That's why this result in the positive overlap. The same way, this is pz and this is s. Again, same phase. This is px and px. This is called sidewise overlap. Okay, you can also try to draw these diagrams like this. Sidewise overlap. Again, this overlapping is as per same phase. This is px. In the same way, this is py. Py of one atom overlapping with py of another atom, resulting in the positive overlap. Now, negative overlap. What is this negative overlap? A negative overlap results when two orbitals with a different phase overlap with each other. Now, again, you can see this is pz of one atom overlap with the pz of another atom. But again, see this. These phases are different. Okay. In the same way, this is pz and this is s. Phases are different. This is sidewise overlapping, px. Again, phases are different of combining or overlapping orbitals. This is again py. This is called negative overlap. There is a third type of overlap that is called zero overlap. A zero overlap will result when orbitals do not overlap at all or do not overlap effectively. Now, in this you can see these are not overlapping. Okay, this is called zero overlap. Now, in this case, this is px and py. The lobes of px is oriented along the x-axis and lobes of py oriented along the y-axis. That's why these are not oriented properly. This is again called zero overlap. A negative and zero overlap of orbitals does not result in bond formation. Now come to nature of covalent bonds. The covalent bond may be classified into two types depending upon the types of overlapping. The covalent bonds, sigma bond and pi bond. Now what is sigma bond? This type of covalent bond is formed by the end-to-end or head-on overlap of bonding orbitals along the internuclear axis. This is called as head-on overlap or axial overlap. In this, the overlapping of orbitals takes place to a larger extent, hence it is stronger. Greater the overlapping, stronger the bond. It may be formed by SS overlapping, SP overlapping and PP overlapping. In this, electron density is concentrated in between the nuclei of bonded atoms. Now we can see formation of sigma bond by SS overlapping. This s orbital of one atom is overlapping with s orbital of another atom like this. This is this part representing the partial merging of atomic orbitals. Okay, and this can also be represented like this. This is s, and this is overlapping, and this result like this. In this case, electron density is concentrated. This is the electron density after the formation of overlapping, and this electron density is concentrated in between these nuclei. Now again, formation of sigma bond by sp overlapping. This type of overlap occurs between half-filled s orbitals of one atom and half-filled p orbitals of another atom. Like this is s orbital of one atom, this is p orbital of another atom. This result in sp overlapping. You can also represent this. This is 1s is overlapping with the 2p, and this result in the formation of sigma bond. Okay, you can also try to draw these diagrams like this. S orbital is spherically symmetrical, and this is p orbital is dumbbell shape, and this is overlapping, formation of sigma bond. Now again, formation of sigma bond by p overlapping. Now in this case, p orbital of one atom is overlapping with the p orbital of another atom, and this overlapping is taking place head to head overlapping. Okay, and this is overlapping, partial merging of these atomic orbitals. You can also represent this. This is p orbital, this is the p orbital of another atom. Constructive interference is taking place, that is, these are in the same phase. This is positive, and electron probability density increases in between the nuclei, this one. Okay. Now pi bond. In the formation of pi bond, the atomic orbitals overlap in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. This bond is formed by sidewise or lateral overlapping of atomic orbitals. In this bond, electron charged cloud is above and below the plane of the participating atoms, and extent of overlapping is smaller, so it is weak. Now you can see this is a weaker bond due to the small overlapping. Okay, now this is p orbital of one atom, p orbital of another atom. Sidewise overlapping is taking place. This is sidewise. Okay, and after the formation of this, we can say this is the internuclear axis, and this is electron cloud above the plane, and this is electron cloud below the plane. Again, remember, these two electron clouds are not representing two different bonds. Actually, one pi bond contains these two electron cloud. One is above the plane and one is below the plane. Okay. Now, what are the differences between sigma and pi bonds? Let us see. Sigma bond, it is formed by the end-to-end overlap of orbital. Pi bond, it is formed by the lateral overlap of orbitals. Sigma bond, the orbitals involved in the overlapping are SS, SP and PP. While in the pi bond, PP orbitals overlap. Okay, overlap of PP orbitals only. Sigma bond is stronger bond, pi bond is weaker bond. In sigma bond, electron cloud is symmetrical about the line joining the two nuclei. In case of pi bond, electron cloud is not symmetrical. In case of sigma bond, it consists of one electron cloud, which is symmetrical about the internuclear axis. While in case of pi bond, there are two electron clouds lying above and below the plane of the atomic nuclei. In case of sigma bond, free rotation about the sigma bond is possible, while in case of pi bond, rotation is restricted. Now, what is the meaning of this rotation? If we keep one atom fixed and try to rotate another atom, then if single bond or sigma bond is there, then this rotation is possible, because in this case electron cloud is symmetrical and electron cloud is only one electron cloud which is symmetrical, while in case of pi bond, electron cloud is lying above and below the plane, and if we try to rotate, that electron cloud will break down. Okay, that's why rotation is restricted in case of pi bond. And sigma bond, it has independent existence, while pi bond, it forms along with sigma bond. Again, remember, if there is a single bond, it is always sigma bond. Okay, and if there is a double bond, one sigma and one pi. If triple bond, one sigma and two pi. That's why we can say pi bond always form along with the sigma bond. Okay. Thank you. Subscribe my channel to get the new videos from this chapter.